Okay, let's get going with this question. All right. So what is the probability of A and B and C? What are we looking for exactly here?
For the intersection.
Yes, absolutely. It's the intersection. What is the intersection here?
So the intersection is 2 plus 5 plus 5 plus 8 divided by 60.
Okay, good. You're on the right track. There, you are on the right track. However, remember each of these numbers are their own entity. Okay, so instead of going this plus this plus this plus that plus that, right? In this case, no, I'm lying. No, you're 100% on point. You're on. But remember, so the and, yeah, no, I'm the one who's bugging. Yes, you're correct. 2 plus 5 plus 5 plus 8 divided by
60.
Right. Teacher, now please just tell me if I'm correct. The intersection that we're looking for should be the one right in the middle. Yes? Should be just that one.
Sorry, Shakoko, for A, B, and C.
Yes, A and B and C. So it's going to be the intersection of all three of them together. So it's not going to be.
It's not going to be 2, it has to be 5.
So if I do 2 and 5 and 5 and 5 and 5 and 8, what you're actually asking for is the probability of A and union B or the union. Now I'm writing intersection. One that you've given me is A intersection with B, union with intersection with C, union with C intersection with. And that's not what we're looking for. Oh, my goodness. Deacon Else, can you hear me?
Yes,
okay.
I can hear you.
You can't hear me. Okay, so what we want is the intersection of all three of them. So in this case, guys, intersection of all three is only going to be the middle part. That part. Yeah, guys, I don't know how to fix it. I'm very sorry. I'm going to have to. Let me just see if it's. Give me 1 second. All right. Can everybody hear me now? Please give me a thumbs up if you can hear me now. Excellent, excellent. Okay, I've had to unplug my external camera because it's giving me issues. Sheesh, I'm gonna have to order a new one from Take It On. All right, so okay, so here's the reason why I'm saying, guys, we shouldn't add all of these numbers up. Okay, it's because some of these numbers repeat, which means they are entities all their own. So I'm gonna ask you guys, I have a 7, a 8, 12, 5, 5, 8, and 13. How many numbers do I have? How many numbers do I have? What is the size of my sample space? Yes, Untati. Correct. Okay, yes, I have 8 numbers. I actually have 8 numbers. So if you were to imagine our sample space, S would look like this. There'd be 2, a 5, a 5, a 7, an 8, an 8, a 12, and a 13. Now, this is my sample space, right? How many elements are in my actual sample space? 8 of them. So the size of my sample space is 8. So when they say, what is the probability of A and B and C? We are only looking for how many elements are there in the intersection? How many elements are in the intersection, guys? How many elements are in there? Count them exactly on Tatile. There's only 1. Good. So the probability of getting A and B and C is going to be 1 over the sample space, which is 10. And I'm realizing we couldn't possibly add them all up because each of them is not it's not like a whole number. It is an entity, each of them are an entity on their own. Okay, so let's think about this one. What is the probability of A or B? And Funzo, if you want to put your hand up again and work through this with me, I'm happy to do that. Okay. So I want you guys to go count up how many elements there are in A or B. Remember, A or B is the union. So we're looking for everything in here. It can be in any of those. Give me an answer for the probability, guys. Remember, the probability is going to be over our sample size. Okay. No worries, Apiwe. Good, that's it. But you need to simplify. Simplify that fraction for me, please. Namisile.
Hello.
Hello, Namisile. What's up?
I'm a bit confused because
Okay.
at my school they said the sample space is all the numbers added up, and you are saying it's all the numbers, like 1, 2,
Okay,
3.
yes. So here is the difference, Namisile. Here's the difference. Because we can see that numbers are repeating themselves. Do you see how they're repeated numbers?
Okay.
Yes. So that's how we know that we are going to use what the number is and not how many of them there are. Okay, am I making sense?
No.
Okay. Okay. So let's say, for instance, all the elements in B needed to equal 17, right? If they all needed
Yes.
to equal 17, right, then we would need all of the numbers added together to add up to 17. You agree with me?
Yes.
Right. You agree with me? They would all have to
20.
add up
Yes.
to 20. Right. They will all have to add up to 20. But because we can see that some numbers are coming up more than once, it means that each of these, it's almost like, think of this as a card with the number 8 on it, and this as a card with the number 8 on it, and this as a card with the number 5 on it. Okay. That's how we are considering. Am I making sense?
Okay, now you're confusing me, but okay.
Oh, okay. All right. I'm sorry, Lucy. I didn't mean to confuse you. Okay. So count how many numbers we have. We have, that's 1 number, 2 numbers, 3 numbers, 4 numbers, 5 numbers, 6.
Yes, I'm not disputing that. What I'm saying is that how we were taught is to add all the numbers.
Mhm.
So when you add all the
Okay.
numbers, it will be your sample space.
Mhm.
But I think the way you do it and the way we do it, when you simplify it, I think it's gonna give you the same number. Or am I mistaken?
Okay. Yes. However, let's say, for instance, Namisile, if these were cards, like let's say deck of cards, playing cards in like the 52 cards that we play, right? If this is the
Yes.
5 of hearts and this is the 5 of spades, how many cards do I actually have?
Huh?
If this is the 5 of hearts and this is the 5 of spades, how many cards do I have?
Isn't it 2?
I have 2 cards because they are 2 different cards. Okay. And then you can say that this is the 8 of diamonds, right? This is actually a queen and not a 12. Do you understand what I mean?
Okay.
Okay. So we're counting how many cards do we have?
Okay.
All right. Okay. So how many elements are in there? It's almost like, let's say, for instance, we were doing, if somebody rolled the dice, right? We could have a 1 here, a 2 there, a 3 there, 4 there. Okay.
Okay,
So
so
we're
can I
looking at
ask
the
a
numbers
question?
themselves. Yes.
So if let's say the numbers were different, let's say
Mm.
for the 8 it was maybe 9, and then for the 5 it was 3. Were we
Mm.
gonna add them or were we gonna count them?
It would depend on what the question wants.
Mhm. Or
Okay,
does it depend on the
depends.
statement?
Yes, it depends on the question. And in this case, I realized that I haven't actually put the question up, so it's a little bit confusing.
Oh,
Yes,
okay.
that's why. Because I haven't actually put the question, the statement that comes at the beginning, and that's why.
Oh, I think that's why
Right.
I got confused.
Mhm. Agree.
Okay.
Agree. I agree with you. Because I didn't put that statement at the very beginning of it. Right?
Okay. Thank you.
You're very welcome. You can understand that because I should have put the statement in there that says these are people, or these are cards, or these are coins. And I didn't actually do that. So that's why it's a bit confusing. All right, let's think about the probability of A or C. So those two together, the union of these two. What's the union of these two peeps? Correct, in Patile. Good. Can count again 6/8. I want you guys to complete the following sentences. We're going to go through them together, and then we're going to do the question. Let's start over here. Right, it says, complete the following statements. Okay, it says, probability of an event E and the probability of an event not E together must equal, who knows? Okay, on Monday. Good, Funzo, that's it. Okay, so the probability of things, or the probability of an event plus the probability of its complement together must equal 1. Okay. Probability of both these things together must equal 1. Okay. I want you guys to read the next question. It says here, the probability of an event that cannot happen is 1. What is the probability of an event that cannot happen? What do you think, peeps? Correct, Danvir, that's it, Storm. So we do have a Storm in the class. Sorry, Storm. Hi. Well done. Okay, good. The probability is 0. Such an event is called what? What do we call it? If we had to describe it in words, what would we call it? Impossible, good. We can say impossible, or not complementary, mutually exclusive. Yes, we could do that. But remember, mutual exclusivity is for 2 events. Correct, Danvir. That's the one I'm looking for. Highly unlikely. Good. Called highly unlikely. If an event cannot take place, we call it highly unlikely. All right. Or we can also say impossible. I don't think impossible is out of reach. All right. Okay. Then it says the probability of an event that is certain to happen is how much? What is the probability of something that's certain? Correct. It's 1. Good. Such an event is indeed called. Correct. Thanks, Danvir. Such an event is called highly what? Good, Namathi. It's highly likely. Good. Highly likely. Excellent. Okay. Good. The last one says the sum of the probabilities of all the elementary events of an experiment is what? What do they all add up to? All of them together add up to how much? Correct, Namisile. Good. That's it. They all add up to 1. Well done, Kunzo. Good. So the sum of all the events together is 1. So I'm going to give you guys the next exercise to do. This one. Okay. I'm going to give you guys the space to do this question. When you're done, pop the favorite emoji in the chat. However, we do have 4 minutes. Okay. Right. Take it away, Pete. I mean, Sila, that was super, super quick. Panelo's making everybody hungry. Yes, absolutely, Funzo, please. Hand up, my sweetie, hand up. All right, beautiful. I think I've got enough answers now for us to continue with the sum. All right, so first thing I'm going to do is I'm going to write out the sample space, and then Funzo's going to take it from here. All right, so it says here, a letter is chosen randomly from the word television. So my sample space is going to be all the letters in here, T, E, L, E, V, I, S, I, O, N, all of those. Okay, so Funzo, question number 1. How many letters are there in the word television?
10.
There are 10 numbers, but we're not just going to say 10. What can we describe this 10 as our what? If this is our sample space, then 10 is our what?
I'm not sure.
Our sample, okay, it's called our sample size. Okay. All right. Sample space is all the letters, and our sample size is then equal to 10. Okay. All right.
Yeah.
So we need to remember the difference between those two. Very important. Okay. Now, tell us about the probability. Find the probability that a letter is in V. What is the probability? So the probability of V is equal to?
Is it 1/10?
It is. It's 1/10. Good. Okay. What is the probability of E, of an E?
2/10.
Good. It's going to be 2/10, but you need to simplify. You can't leave it at 2/10. So what's our answer actually going to be?
It is 1/5.
1/5. Now, note here, the next one says the probability of not an E. What do we call not in mathematics? It's called a what?
It's
Starts
what
with a
is it
C.
called again?
There it is. And now I've given it to you in the chat.
Yeah, the complement.
Complement. Good. So, what is the complement of anything that is not E?
So the answer will be 8/10, which is 4/5.
8/10. Good. It's 8/10, which is equal. Good. Excellent work. Right. Now, the next one here says, what is the probability that we'll have an E or a Z? Now, or is the union, you see, right? So there's a particular rule that we've learned about the union. Which rule was that we learned about?
So, ma'am, can you hear me?
Yes, I can.
Ma'am,
Mm,
can you hear me?
I can hear you, Funzo. Oh no, Teacher Nels, can you just give me a thumbs up if you can hear me?
Yeah, I can hear you.
Okay, yeah. I thought maybe the the problem is coming from my side, but it looks like it's coming from Funzo's side. Okay. E union V. Okay. I just realized we don't have the intersection, so we can't actually use it. Okay. Funzo, I'm gonna mute Funzo because like now she's gone away, but somebody has already given us the answer. Okay. So we know that there are two E's and a V. So we're gonna have 3/10 as the answer. Okay. All right, peeps. Anybody else give me a thumbs up if you can hear me and you got the correct answer. Excellent. Okay. Because I feel like everybody else is having a bit of trouble then hearing me. Some of the stuff down. All right, here's our next challenge, peeps. You've got five minutes because it's quite long. Read the information, answer each of the questions, guys, and then give me your favorite emoji in the chat once. Okay. Okay, I'm just going to do this for those of you who can't hear me. Ah, yes, Samuel. It is quite fun, especially when you understand what you're doing. 'Yes, Funzo, answer the questions. One minute, guys. I'm going to get ready to answer this question really quickly. So I'm going to move this up a little bit. Yes, Mara, correct. Because the subsets, there are only two subsets, you're only going to draw two circles. Okay, because we only have subset A and subset B, two circles. All right. Speaking of, let me put my two together. Ah, I love to hear it. That's amazing, Samuel. Awesome. Let me see, Le, what's up?
Oh no, is everyone done?
I don't think she's going to say, ma'am, I want to answer the question.
Okay.
Let me
yes,
see
I
it.
do. I wanted to answer the
Yay!
question.
Yay, absolutely. Okay, that's time even. All right, let's start from the beginning. Okay, so it says, consider the given events A and B that involve numbers taken from the first 10 positive integers. So let me see, this isn't actually our sample space. I'm going to need you to give us our sample space before we get started. What is S? What is our sample space exactly?
10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay. It's not just going to be 10. Our sample size is 10, but what are the elements in our sample space? Going to be 1 and
2, 3, 4, 5, 6, 7, 8, 9.
hooray! 3, 4, 5, 6, 7, 8, 9, and 10. Okay, that's our sample space. Now, let me see if I ask you, what is our sample size? What is our sample size?
10.
Good. We have 10 elements in our sample space. Okay, are we seeing the difference there?
Yes.
Okay, good. All right, let's talk about this one. It says, list sets A and B. Now we know that A and is the intersection. So if we list set A intersection B, what numbers are going to come up?
1 and 3. We didn't draw the Venn diagram.
Not bad. So okay, let's start at the Venn diagram. So A, B. All right. Okay, so we know in set A and B, yes, you're correct. There's 1 and 3 in the middle, and then we've still got 2, 4, 5, and 6. And over here we still have 7, 8. What's missing? What goes on the outside?
9 and 10.
9 and 10 goes on the outside because those two are missing. Excellent. Now, tell me, what is A intersection B?
1 and 3.
So 1 and 3. Excellent. 4, what do we call or again? The what?
The union.
Good. So what is a union B? What is it here?
1, 2, 3, 4, 5, 6, 7, 8.
Good. 1, 2, 3, 4, 5, 6, 7. Now, let's look at C. So, the number from the first and positive integers randomly selected, find the probability. Now, when we look for the probability, we're not going to use the sample space. We don't need the sample space now. We're going to use the sample size. Okay.
Yes.
We're going to use how many elements there are in each. So, what is the probability of A?
6 over 10. Simplified 3
Good.
over 10.
6 over 10, simplified. Good. 3 over 5. Beautiful. Good. Now, what is the probability of A intersection with B?
2 over 10. 1 over 5.
2 over 10, which is 1 over 5. All right. All right. What is the probability of A or B, which is a union B?
8 over 10, which was 4 over 5.
Beautiful. Is it difficult?
No, it's not.
Not at all. Not at all. Okay. Last question. Are the events A and B mutually exclusive?
No,
No. One.
because there's an intersection in the Venn diagram.
You know what? 100%. You already passed the whole of probability. There's no need for anybody to test you ever again. You got it. All of it. 100%. Well done.
Thank you.
Well done. Okay, very nicely done. Okay, very, very well done. Good. And that's also another way for us to look at it. Good. A and B, or A intersection with B, is not equal to 0. Therefore, they're not mutually exclusive. Good, because there's an intersection. Excellent. All right, let's get to the next one, guys. Sure, you guys are flying through these. Okay, you guys are flying through these. Here's the next one. It says boxes A and B contain 4 counters each. Box A contains 2 red and 2 green, and box B contains 1 red and 3 green counters. Box is chosen at random. and then a single counter is selected. Before we even continue, I need to ask you guys, okay, how many events are happening in each of these? How many events do we have happening? Think about this, peeps. Yes, Danvir, good. Do you know why? Because I see a question mark there, and I don't think we're sure why we're saying 2 events. Okay, think about this. Look at what they're telling us. They're telling us that a box is chosen at random. First, we choose a box. And then after we choose a box, what happens? What happens after we choose a box? Anybody got an answer? Correct. This is considered as an event taking place, but after we picked a box, then a single counter is selected. So there are 2 events happening one after the other. Here's my next question. These events, are they dependent or independent? Are they dependent or independent? Kunzu says independent. What do we think, guys? Are they dependent or independent? Okay, think about it carefully. Don't just answer. Think about it. Okay, good, Danvir. But remember, dependent, yes, good. It should be dependent. Okay, and I hope we all understand why it's dependent, because the counters that I get to choose are dependent on the box that I choose. Okay, so first I have to choose a box. So once I've chosen a particular box, again, however many counters are inside are going to be determined by which box I chose. So these are not independent events, they are dependent events. Give me a thumbs up if that makes sense. Okay, because even the counters determine which box I choose. Getting one response. I hope everybody else is with me. Okay, excellent, guys. Excellent. All right, let's answer these questions. You've got 4 minutes. All right, okay, let's make it 5. There are 5 questions, 5 minutes. This one is a bit of a tricky one, guys. So take your time. Remember, guys, dependent is always the product rule. Okay, so we're always going to use product of one and then the other. Right, it's the product. Ayana, does it ask for a tree diagram somewhere? Okay, skip C. Skip C, please. Okay, let's not do C. And I only just realized it, but we've learned about dependence and independence. Any by any chance, you know why they just want to teach tree diagrams in grade 10? I mean, they're so simple. Sure, Mara, you're very fast. I'm not 100% sure why they just want to teach it in grade 10. And the funny thing is, our boys over here do it in grade 9. So it's shocking to me that they don't do it until grade 11. It's such a simple concept. Sequences already been taught it. So, I mean, guys, it's not even that complicated. And it helps, really helps with dependent and independent events. So I'm just, yeah. Okay. So now, Lucila, please don't do C. Okay. Two more minutes, guys. Remember, pop your favorite emoji in the chat when you're done. me, what is that? Is that a kimono? Oh, I see. I see. Nice. 1 more minute, peeps. And Sunny's out here feeling like Alicia Keys. We see you. Hello, Amber. Lovely emoji, love it. Okay, no worries. That's okay, Samuel. Go rest a little bit. All right, guys. That's fine. Okay. Let's have a look at these quickly. Now, I need us to remember, guys, that there are going to be two events that take place one after the other. So we need to break this up into event 1 and then event 2. Yeah, 2 things are going to happen one after the other. So let's start with the probability of box A. Guys, if I take out the probability of box A, what is the probability that I will pick box A? Pop your answer in the chat, please. Correct. Namisile, not 2/4, just 1/2. And the reason I'm saying that is because how many boxes do we have? How many boxes do we have? 2 boxes. So we're choosing from the probability of 1 of 2 boxes. So the probability of picking box A is 1/2. What is the probability of picking box B? Probability of picking box B, said Amber. Correct. 1/2. 1/2. Okay, so that's event A or event 1. These are the probabilities of event 1. Okay. Okay. Now, event 2 is going to be dependent on what happens or which box we choose in event 1. Right. So event 2, okay, we're going to get 2 different probabilities there. We're either going to get, for the first box, for box A, we're either going to get the probability of green or we're going to get the probability of red. And for box B, same thing. We're going to get the probability of green or we're going to get the probability of red. Now, in box A, we're only going to concentrate on A for a little bit. What is the probability of picking a green counter? Correct, offense. Good, Amber. That's it. Now that's where the 2/4 comes in. So this is now 2/4, which is the same as a half. What is the probability in box A of choosing a red counter? Same. Correct, offense. It's the same. It's also going to be 1/4 or 2. 1/2 or 2/4. Right. Now let's go to box B. Let's go to box B. Let's go to box B. In box B, what is the probability of picking a green counter in box B? Correct, 3/4. Excellent, 3/4. And what is the probability of picking a red counter? 1/4. 1/4. So each of these probabilities are going to be linked. Right. So let's start with the first one. The first one says, what is the probability of selecting a red counter from box A? Now, the box is going to come first, not the counter. The box is going to come first. So we want the probability of A and then red. So we're going to go find them exactly that. So the box or the probability of box A is 1/2 times the probability of choosing red in that box, which is 1/2. It's still the same, it's going to be 2/4, but we're going to simplify it to 1/2. So what is the probability of box A and then a red counter? We're multiplying, guys. What's my answer? Correct, Upense. Beautiful, good. Not 2/4, Namisile. Right? Remember when we're multiplying, we multiply top. 1 times 1 is 1, 2 times 2 is 4. I want everybody to give me a thumbs up if they understand what I've just done. Is everybody with me? Are we all together? Good, excellent. Good stuff. Okay, good. So we need to take them a step at a time. Right, now let's look at the next one. The next one says, what is the probability of selecting a red counter, but this time from box B? So we're going to look for the probability of B and then a red counter. Okay, so the probability of picking box B is going to be 1/2 times what is the probability of picking a red counter from box B? Correct, 1/4. So we're going to have 1/2 times 1/4, which is equal to how much? Correct, 1/8, not red over 8, 1/8, correct, 1/8. Okay. Good, all right, excellent. Okay, we're going to stop it there because I did just realize that the only way we're going to be able to answer question D and question E is if we have tree diagram. And at the moment, we don't have a tree diagram, so we can't figure that out. Okay. Tree diagrams are very helpful. I don't know why they don't teach them in grade 10. Seems like a waste to me, to be honest. All right. Thank you so much, guys, for joining us. If any of you want a little bit more practice, we have this over here. You guys can have a look at this question, right? It's a little bit more, well, not really. It's quite simple. Very simple. Okay. It's an easy one. I'm going to go fetch Blake Keen's question. Hey, teacher Nels, that last one that we did there, I think it was really nice.
Yeah.
Yeah, as well. Yeah. If you guys want a nice challenge, here's a nice question. You guys can take a screenshot of that and go and try. It's a very, very nice question.